Hello everyone, welcome in Learn CHE. Here we are with our 10 MCQ series, and today we are going to discuss about heat transfer 10 MCQs, and this is our part 2. So if you haven't watched part 1, please watch part 1 because there was a very basic question of heat transfer, and in this video we are also going to take some basic question and some conceptual questions of heat transfer. So before starting the video, if you haven't joined Learn CHE YouTube channel, please join it and hit the bell icon to get the latest notification of Learn CHE's videos, right? And if you have any doubt in any subjects, any topic, please let me in the comments box. I will make the video separately for that topic. So let's start with our first question. So the first question is the unit of thermal diffusivity is. Okay, here are the four options. The first one is meter square per hour. Second one is meter square per hour degree Celsius. The third one is kilocalorie per meter square hour. And the fourth one is kilocalorie meter hour degree Celsius. Okay. Now the first thing is, what is thermal diffusivity? Okay, what is the formula of thermal diffusivity? If you know that, then you can easily solve this question. So the formula of thermal diffusivity is denoted by alpha, right? And the formula of thermal diffusivity is thermal conductivity divided by the product of density into heat capacity, right? Suppose that is C. Okay, now what is the unit of thermal conductivity? The unit of thermal conductivity is watt meter Kelvin. Now the unit of density is kilogram per cubic meter, and the unit of heat, that is joule per kilogram Kelvin. We can simply write it. Okay, here we can also write kilojoule, but I am writing joule per kilogram Kelvin, right? Now what will happen, we can simply see that kilogram and kilogram will be cancelled out, Kelvin and Kelvin will also cancel out. Now here is meter and this is cubic meter. Okay, when it will go here, so it will just cancel out from here and it will become meter square, right? Now just see that I'm just writing here. Now what I'll get watt meter square, this meter, right? And here is joule. So I'll write here simply joule. Then how can I write the watt? Watt can be written as joule per second, right? So this joule and this joule can be cancelled out and my answer will be meter square per second. I hope you are getting everything what I am writing here, because this is very simple. If you know the formula, then you can easily solve the question. Okay, here is meter square per second. Now what will be the right answer? The right answer will be option A. Okay, meter square per hour, and here the unit of time is in hour and here in second. Okay, this is a SI unit, and here time unit is converted into the hour. So simply you can say that the unit of thermal diffusivity is meter square per hour. Okay, now the next question is the rate of energy transferred by convection to that by conduction is called. Okay, here are the two terms that is very important. That is convection, the rate of energy transfer by convection to conduction. Okay, and here are the four options. The first one is Stanton number, the second one is Nusselt, third one is Biot, and the fourth one is Peclet number. So listen, the energy transferred by convection to conduction. Okay, suppose I am just writing here rate of energy by convection divided by rate of energy by conduction, right? So we can simply, I'm just simply writing here the formulas of rate of energy by convection. and then convection. And I am writing here the formula of Newton's law first, and that is H A delta T. Okay, and the second one is weight of energy by conduction, and here I am writing the formula of Ka, that is delta T by X, or I am simply delta X, and instead of delta here is, that is Ka delta T, right? So instead of writing delta X, I am writing here L simply, right? So delta T and delta T can be cancelled out. A and A will be also cancelled out. So it will become H L by K. Now what is that? This is the formula of Nusselt number. Okay. So right option will be Nusselt number, that is B. And Nusselt number is also how we define the Nusselt number: convection heat transfer to conductive heat transfer, right? So this will be our answer, HL by K. Now the third question is thermal conductivity of wood depends on, okay, wood. Here we are talking about wood, right? And what is thermal conductivity? Thermal conductivity is the ability of the material to conduct heat. Okay, this definition is very important, guys. We are talking about thermal conductivity of wood. Okay, and what is thermal conductivity? Thermal conductivity tells us about the ability of the material, and here is the material is wood. Thermal conductivity of the wood to conduct heat. Okay, the ability of the wood to conduct heat is called the thermal conductivity of the wood. Okay, so it will simply, if I am talking about the ability of wood to conduct heat, so definitely it will depend its moisture. It will definitely depends on moisture as well as density and the temperature as well. Okay, so that's why the right option will be all of the above. Why? Because if the moisture will decrease or increase, definitely the ability will affect. If the temperature will decrease or increase, definitely the thermal conductivity increase or decrease, right? Same with density. So that's why the answer will be all of the above. Now, and the fourth question is the unit of overall heat transfer coefficient is. Okay, here are the four options: 1, 2, 3, and 4th. That is watt per meter square Kelvin, watt per meter square, watt per meter Kelvin, watt per meter. Option is not going to be right option. Why? Because this is a unit of thermal conductivity, right? Then if we talk about the Newton's law, okay, if we are talking about the Newton's law, and we have to write Newton's law with respect to overall heat transfer coefficient, so I simply write it Q is equal to U A delta T, right? So here we can simply say that what will be the unit of that U, and we have to, and this U is a overall heat transfer coefficient. Okay, the unit of Q, is watt. Then the unit of A, that is the area, and its unit is meter square, and the unit of temperature, that is in absolute scale, and its unit is Kelvin. Now what will be the answer? The answer will be watt per meter square Kelvin. Option A is going to be right answer, right? It is also very easy question. These types of questions are asked in sometime in competitive exams, sometime in viva, sometimes in generally in the classroom as well. And if you know the basics, then you can easily solve the question. If you don't know the basics, then it is going to tough for you to solve the question. Okay, so the simple thing is strong your fundamentals, strong your basics if you want to be a good engineer. Now the fifth question is LMTD, that is log mean temperature difference in case of counterflow heat exchanger as compared to the parallel flow heat exchanger is same, low, higher, and depends on the area of heat exchanger. Okay, so first we talk about the counterflow, right? So in the case of counterflow, suppose this is the graph, right? So for the counterflow, suppose from here hot fluid in, okay, from here the hot fluid in, that is right. And what is the meaning of counterflow? The counterflow means if hot fluid is going into this direction, then cold fluid will go into this direction, right? So direction are not same. So here cold fluid will out. Okay, and suppose in this side I can simply write that if the hot fluid is enter from here, so simply its temperature will decrease. Why? Because its energy will transfer into the cold fluid, right? So I can simply write here THO, and here that TC out means the temperature of cold fluid outlet. Okay, so I can simply make the graph like that, and here like that, and this is the TCI. Are you getting my point? What I want to say? I want to say that from one side of the heat exchanger, cold fluid is inlet, and from there the hot fluid is a outlet. Okay, the outlet is a outlet for hot fluid, and the same from this side, if I talk about, then here is hot fluid inlet, and here is the hot fluid outlet, sorry, cold fluid outlet. Okay, and that's why the graph is like that. So we can simply say that this is the graph for the counter flow. Now just make the graph for the parallel flow, and in the case of parallel flow, the condition is like that. The hot fluid is going into the this direction, and same the cold fluid is also going into the same direction. So we can simply say that suppose from here the hot fluid is in, and same suppose here the cold fluid is in. And how will be the graph? The graph will be simply the hot fluid will decrease the temperature, it will like that, and the cold fluid will increase the temperature. The graph is like that, and here is the T H out, and here is the C T C out, right? And this is the graph in the case of parallel flow, and this is the graph in the case of counter flow. Now can you please let me in the comments box what type of pattern is better in the case of LMTD? Is LMTD is better in this case or this case? This is very simple question now, because I have plotted the graph, and from graph we can simply calculate that which arrangement is better. Okay, where is the change is less and where is the change is high, we can simply calculate now. Okay, and here the direction will be same in that direction, and here is the direction is not same, right? Now the sixth question is, the transfer of heat by molecular collision is smallest in. Here are the four options: solids, liquids, gases, and none of these. Okay, here we are talking about the molecular collision, right? Means the collision of molecules. Collision of, suppose here are the molecules, and it depends upon the collision of the molecules, right? So in the case of solids, it is very strongly packed. Okay, and we know that the conduction is occurs in the solid due to the vibration, and we can say due to the molecular cohesion. Okay, so here in solids case and liquids case, it is going to definitely it will happen that after that we see the conduction, right? So the right option will be the gases. Why? Because there are the molecules are very far away. Okay, and when we supply heat, then molecular collision is less as compared to liquids and solids. Okay, and in solids we know the conduction is happens due to the free electrons. Okay, and that free electrons provide the energy to the adjacent layers, and the vibration or the molecular collision occurs. That's why the right option will be the C, that is gas, right? That's why the option C is the right option, because we are talking about here the molecular collision. The seventh question is, in a cell and tube heat exchanger, baffles are provided on the cell side too. Okay, why baffles we use? Okay, so here are the option is improve the heat transfer. Yes, it improve the heat transfer. Why? Because it creates the turbulence as well as it give the better contact for the heat transfer. Okay, it provide the better contact or area for the heat transfer. So yes, The option A is going to be the right option. Provide support for tubes. Yes, it is also the right option. Prevent stagnation of cell side fluid. Yes, this is also the right option. Okay, suppose if A and B are the right option, then we cannot, so there are not the option like both A and B. So simply the right option will be D, all of these. Okay, baffles are very important in many cases. Okay, baffles and fins also very important because they provide the area, okay, for better heat transfer, as well as it provides the support as well, right? Now the eighth question is the product of Reynolds number and Prandtl number is known as. Okay, so here are the Reynolds number. Reynolds number is NRE into NPR. Okay, so what is Reynolds number? Reynolds number is U, that is velocity, density into length divided by viscosity into what is the Prandtl number? That is momentum transfer, that is mu, by thermal diffusivity, that is alpha. Now we can simply write here U rho L by mu, okay, into what is that? This is a kinematic viscosity, right? So how can I write it? I can simply write it as the dynamic viscosity divided by density into alpha, right? So it will be cancel out, rho to rho also cancel out, so it will become U L by alpha. Okay, now this is the formula for Peclet number. This is the formula of Peclet number in the case of heat transfer. Okay, in the case of mass transfer, okay, whenever we are talking about the thermal fluids, so here the product is with Reynolds number, the product will be Prandtl number. Okay, and suppose if we are talking about the mass transfer, so it will be transfer. Okay, so instead of Prandtl number, here will be Schmidt number. So the right option will be here, Peclet number is going to be the right option. Now the value. Okay, so ninth question is the value of Prandtl number for air is about to. Here are the four options: 0.1, 0.3, 0.7 and 1.7, right? So how can I calculate this? In last question we discussed about the Prandtl number, right? And the Prandtl number was nu by alpha. Okay, so what we can do, we can simply calculate the kinematic viscosity, and from steam table we can also see what is the kinematic viscosity for air, then what is the thermal diffusivity for air at a specific temperature. Okay, say suppose I have written here 1.48, okay, into 10 power 5, okay, that is a kinematic viscosity at temperature 15 degrees Celsius. Okay, so what will be the unit? The unit will be meter square per second. And what is the thermal diffusivity at 15 degrees Celsius? It is 2.009 into 10 the power 5. Okay, that is also meter square per second. Okay, when I'll cancel it out, so it will become 0.76 approx, right? And this minus 10 power minus 5 and 10 power minus 5 will be cancel out, and unit will be also cancel out because this is the dimensionless number. So option C is going to be right option. Okay, you can also calculate it at any different temperature, suppose at 10 degrees Celsius, 15, 20, and you will find the 0.7 because it is a constant value. Now the 10th question, this question is very simple question. Okay, because we do not have to do anything. Okay, for this question I am just telling you one thing. Here are the four options, right? Universal gas constant unit, we know the unit of kinematic viscosity, that is meter square per second. Just in the last question we discussed. We also discuss about the unit of thermal conductivity, that is watt per meter Kelvin, and we do not know the unit of Planck's constant or universal gas constant. This unit we all know, right? Kilojoule per kilomole Kelvin if we are talking about the mole, or if we are talking about the in the mass. Okay, if we are taking about the mass, then we can simply say kilojoule per kilogram Kelvin, right? So now what we have to do, we have to simply write the formula. Okay, the formula is this. I have tell you the unit of kinematic viscosity, that is not the right option. The thermal conductivity is also not the right option. Why? Because here that is a watt, and watt can be written as joule per second. Okay, but here is meter and Kelvin as well. That's why this is also not the right option. Now you have only two options, A and okay. What you can do, you can simply write the formula for R. Okay, first you have to simply write the unit of R and unit of Planck's constant. Okay, then you can find out what will be the right option. And very simple question. I think 90% of you can guess the right option, and let me in the comments box what will be the right option for this question. Also tell me the value of Planck's constant. What is the value of Planck's constant? Because this is mainly asked in the examination, right? What is the value of Planck's constant? Now here is the question for you all, and you all have to give me the answer of this question in the comments box. Okay, and the question is up to the critical radius of insulation, and here are the four options. The first one is added insulation will increase heat loss, added insulation will decrease heat loss, convective heat loss will less than conductive heat loss, and the fourth option is heat flux will decrease. Okay, up to the critical radius of insulation, what is going to be the right option here, and what is critical radius? Okay, what is the significance of that? Please let me in the comments box, right? So today we discuss about the 10 MCQs of heat transfer, right? So if you have any doubt in any question, please let me in the comments box, and I have given you the one question. Also write the answer of that question and give me the answer in the comments box. If you are not, if you are not able to write the right answer, I'll explain in the comments box as well. Okay, so if you like that video, please like the video and share with your friends in groups. And if you haven't joined the Learn CHG YouTube channel, please join it as well for our latest videos. Thank you for watching. See you soon.